Good evening and welcome. If you are listening from a warm bed or from a quiet room with the lights low, you do not need to do anything at all. You can let your breathing find its own pace. You can let your attention soften at the edges. Tonight, we are not traveling away from home. We are simply noticing where home already is. The Milky Way is not a picture hanging in the distance. It is the wide, steady environment that surrounds every night that you have ever lived through. Even with your eyes closed, you are inside it. Everything familiar, the earth, the moon, the sun, and the thin air above your roof, all of it is moving together through a vast, calm structure that has been here for billions of years. And if these quiet journeys through science help you unwind, you are always welcome to like or subscribe. It helps others find their way here too. Now, with no urgency at all, we can begin. The Milky Way is a galaxy we can only understand from within, because we are embedded inside its disk. From our position, the galaxy is not a single object with clean edges. It is a direction, a depth, a gentle brightness threaded through the sky. When you look up on a very dark night, you are not seeing a distant thing, the way you might see a mountain from far away. You are seeing along the plane of a great, flattened system, looking through layers of stars and dust that share a common rotation. The view is like standing in a forest at night and noticing that the trees seem denser in certain directions, not because the forest changes suddenly, but because your line of sight passes through more of it. The Milky Way has that same quiet intimacy. It does not sit in front of us, it holds us. The Milky Way's familiar band in the night sky is the galaxy's disk, seen edge-on from our vantage point. That pale, milky ribbon is not a cloud in space. It is the combined light of countless stars whose individual points blur together when they are too faint, too far, or partly veiled. In some areas, the band looks brighter and richer. In others, it is interrupted by darker lanes. Those dark lanes are not empty. They are places where fine dust grains drift between us and distant starlight, softening and dimming what lies beyond. The brightness, the dimness, the subtle mottling, it is all the result of depth. It is what a great rotating disk looks like when you view it from inside, surrounded by distance in every direction, and still mostly sheltered within the same plane. The Sun sits in a relatively calm region of the galaxy, not close to the crowded central core. Our star is not near the Milky Way's bustling center, where stars are packed more tightly and the environment is more intense. We live further out, in a neighborhood where the average spacing between stars is generous, and where long, stable orbits are easier to maintain. This is not a lonely place, and it is certainly not empty. It is simply less dense, less compressed, more like a quiet suburb than a city centre. Over immense stretches of time, that gentler setting has mattered. It has allowed the solar system to move through the galaxy without constant close encounters, and to keep a steady rhythm. In a universe full of motion, our region is one where motion tends to be smooth. The solar system travels around the galactic center as part of the Milky Way's general rotation. Nothing here is still, not the stars, not the gas between them, not the delicate dust that drifts like smoke in slow currents. The Sun carries us along a wide orbit around the galaxy's center, and that orbit is not a straight path, but a continuous curve, like a slow walk around a circular lake that takes longer than any human history. The sensation of that movement is not felt as wind or vibration. it is felt as stability. Gravity does its work quietly. It keeps the disk together, keeps the stars from flying away, and keeps our own path consistent enough that the night sky changes only gradually across generations. Even when you feel at rest, you are moving with the galaxy. The Milky Way's spiral pattern is not a set of fixed arms made of the same stars, but a long-lived pattern that stars drift through. When we picture spiral arms, it is easy to imagine them like painted stripes on a spinning wheel, with the same material always forming the same shape. But the galaxy is more subtle than that. The arms are better thought of as regions where material tends to bunch up, where gas becomes denser, where star formation is more likely. Stars are born in these busier regions, and then, over time, they continue onward in their own orbits, gradually drifting away from the arm that once cradled them. The pattern can persist, even as the participants change. It is like a slow traffic wave on a motorway, where the wave of density moves along, even though the cars within it come and go. This makes the spiral arms feel less like rigid structures and more like gentle habits of motion. In the Milky Way's spiral arms, new stars tend to form where gas clouds are compressed and cooled. Gas in a galaxy is not evenly spread. It gathers in vast clouds, and in some places those clouds are nudged, squeezed, or stirred by the galaxy's dynamics. Where the gas becomes denser, it can cool more effectively, and in cooling, it can begin to collapse under its own gravity. Over time, that collapse can create new stars, and those newborn stars often shine hot and bright, lighting their birthplaces from within. The arms, then, are not merely decorations. They are regions of continuing renewal. They are places where the galaxy quietly converts diffuse material into new suns, again and again, in a process that is slow, patient, and constant. The space between the Milky Way's stars is not empty, but filled with a thin interstellar medium of gas and dust. Between stars, there is a faint, widespread mixture of hydrogen, helium, and trace heavier elements, along with tiny solid grains of dust. It is not like air. It is far thinner, far more rarefied, and yet, across the scale of the galaxy, it matters. It carries magnetic fields. It responds to shock waves. It provides the raw material for future stars and planets. It also shapes what we see. Dust grains scatter and absorb light, making distant stars appear redder, dimmer, or entirely hidden along certain lines of sight. In this way, the interstellar medium is both the galaxy's atmosphere and its memory. It is made from the remnants of earlier generations of stars, spread out and mixed, waiting quietly for its next role. Much of what we call the Milky Way's dark lanes are dense dust clouds that block visible starlight. When you see a dark rift cutting through the bright band, you are not seeing a gap in the galaxy. You are seeing the presence of material close enough to us that it can hide the more distant glow. Dust is very efficient at this. A small amount, spread across long distances, can soften and dim the light behind it. These lanes often trace the same plane as the rest of the disk, because that is where the gas and dust are concentrated. They are signs that the galaxy is layered. There is a foreground and a background, and in between them, a quiet, floating veil. Even darkness in the Milky Way can be a kind of substance, a gentle obstruction, rather than a void. The Milky Way has a central bulge, a thicker region of stars that rises above and below the flat disk. If the disk is like a broad, rotating plate, the center is more like a swollen hub. In that inner region, stars are more densely packed, and the galaxy's structure becomes less like a thin sheet and more like a rounded volume. From our position, we cannot see the very center clearly in visible light because dust obscures it. But we can still sense its direction in the sky, and we can learn about it through other kinds of light and through careful mapping. The bulge is a reminder that galaxies are not perfectly uniform. Their shapes are the accumulated outcome of rotation, gravity, and time, layered into a form that feels both orderly and organic. At the very heart of the Milky Way lies a supermassive black hole known as Sagittarius, a star. This is not a dramatic monster roaming the galaxy. It is a compact central anchor quietly influencing the orbits of stars near it. Its presence is inferred and measured by the motion of those stars, which sweep around an unseen point with remarkable speed and precision. Over many years of observation, their paths reveal a strong, concentrated mass in a small region. The black hole is part of the Milky Way's structure, but it is not the source of the galaxy's overall gravity. The galaxy is not held together by a single object. It is held together by the combined mass of its stars, gas, dust, and the larger, unseen component we call dark matter. The central black hole is significant, but it is one feature among many in a much broader system. The Milky Way's rotation is not like a solid record spinning, because different parts orbit at different speeds. In a solid object, every point completes a turn in the same amount of time. But a galaxy is not solid. It is a vast collection of independent orbits, each responding to gravity. Inner regions tend to orbit more quickly than outer regions. And yet, the details do not follow the simple expectations we might have if all the mass were concentrated where the light is brightest. This is one of the quiet clues that much of the galaxy's mass is not directly visible. Still, for our purposes tonight, the important feeling is the same. The Milky Way is not static. It is a slow choreography of many paths, each one steady, each one curved, each one guided by an invisible center of pull. The Sun's path around the galaxy is accompanied by a smaller, gentle up and down motion through the disk. Our orbit is not perfectly confined to a single plane. Over long timescales, the solar system drifts slightly above and below the midline of the galactic disk, like a calm boat rising and falling on a very slow swell. This does not mean we leave the galaxy's environment. It is more like moving through different layers of the same wide structure. The disk has thickness, and we move within it, not on a razor-thin surface. This subtle vertical motion is part of what it means to live inside a living galaxy. The Milky Way is not just a flat picture. It is a three-dimensional habitat, and we are gently weaving through it. From where we are, the night sky is a map of the Milky Way's structure, but it is a map distorted by our location. The sky does not present the galaxy evenly. We see more stars and more brightness when we look along the disk, because our gaze passes through more of the galaxy's material. When we look up or down away from the disk, the sky becomes darker and less crowded, because there are fewer stars in those directions. This is not because the galaxy ends abruptly above and below us, but because the main concentration is in the disk. The sky, then, is not merely decoration, it is evidence. It is a gentle imprint of geometry on our experience, showing us that we inhabit a flattened, rotating system where direction matters. The Milky Way contains star clusters, groups of stars born together that still travel through the galaxy as loose families. Some clusters are tight and ancient, holding together for a long time. Others are younger and more fragile, gradually dispersing as each star finds its own orbit. The important point is that not every star is born alone. Stars often form in groups within the same cloud, and for a while, they share a common origin, a common motion, a common chemical signature. Over time, the galaxy's tides and small gravitational encounters stretch these families apart, until the siblings are scattered across a wide region of space. The night sky, then, is a mixture of strangers and relatives, of stars that have never met and stars that once warmed the same cradle of gas. The Milky Way is filled with stellar leftovers, such as white dwarfs and neutron stars, quietly marking the long history of earlier generations. Not every star that ever formed in the galaxy is still shining in the same way. Many have already reached later stages, becoming compact remnants that glow faintly or emit energy in forms we cannot see with our eyes. These remnants are not rare curiosities. They are natural outcomes of stellar life. Over billions of years, the galaxy has produced, aged, and recycled enormous numbers of stars, and their remains are part of its ongoing inventory. When you imagine the Milky Way as a calm environment, it can help to remember that it is also an archive. It contains youthful brilliance and ancient quietness side by side, layered together in the same slow rotation. The Milky Way's chemical richness has grown over time because stars have steadily made heavier elements and returned them to interstellar space. In the early universe, there was mostly hydrogen and helium, with only tiny traces of heavier material. The elements that build rocks, oceans, and living bodies were not always present in the same abundance. Over time, generations of stars fused lighter elements into heavier ones, and then, through stellar winds and end stages, they released some of that material back into the surrounding medium. This enrichment happens gradually, like a patient seasoning of the galaxy's gas. It means that later generations of stars, including the Sun, can form with more of the ingredients needed for solid planets. The Milky Way, in that sense, has slowly learned to make complexity, not through a single event, but through steady repetition across deep time. Even in our local region, the galaxy's magnetic fields thread through space and gently influence the motion of charged particles. These fields are not something you could point to with your hand. They are invisible lines of influence, woven through the interstellar gas. They can guide the paths of cosmic rays, shape the edges of gas clouds, and contribute to the texture of the galaxy's diffuse medium. Over long timescales, magnetism becomes part of the galaxy's quiet architecture, working alongside gravity rather than competing with it. Gravity gathers and holds, magnetism shapes and channels. Together, they help create the layered, filamented appearance of the Milky Way's gas when we observe it in different wavelengths. Even in the vastness, there are subtle structures, like gentle grain in wood. The Milky Way is surrounded by a halo, a more spherical region containing old stars, globular clusters, and extended material beyond the disk. When we think of where we live in the galaxy, the disk dominates our imagination because it is where most of the bright stars and the visible band reside. But the galaxy extends beyond the thin plane, far above and below and around it all. there is a halo that holds some of the Milky Way's oldest stellar populations, as well as many globular clusters, dense swarms of stars that have survived for very long times. The halo is quieter in the sense that it is less crowded and less active in star formation, but it is still part of our environment. It is like a dim, extended outskirts that wraps the galaxy in a soft, wide presence. Globular clusters orbit the Milky Way as ancient, densely packed groups of stars that have remained bound for billions of years. These clusters are like small, enduring cities of stars, each one containing many thousands to millions of suns, held together by their own collective gravity. They are older, on average, than the stars in the disk, and they carry the signature of an earlier era in the galaxy's history. When you imagine the Milky Way's slow evolution, globular clusters feel like steady witnesses. They have orbited through the galaxy's changing conditions, through the quiet growth of its disk, through minor mergers and gradual enrichment. Their light is not flashy. It is concentrated and calm, like lanterns that have been lit for a very long time. The Milky Way is not isolated, because smaller galaxies and star streams are still being absorbed into it over time. Our galaxy lives in a neighborhood. It has companions, and it has a history of interaction. Some smaller galaxies orbit nearby, and over long timescales, gravity can pull them closer, stretching them into streams of stars and gradually incorporating them into the Milky Way's halo. This process does not always look like a collision in the everyday sense. It is more like mixing, like slowly stirring cream into coffee, where the edges become threads and the threads become faintly blended. Evidence of these past and ongoing mergers can remain as coherent streams of stars moving together through the halo, still remembering their shared origin, even as they become part of a larger whole. When we look toward the densest parts of the Milky Way, we are often looking through so much dust that infrared and radio light become our clearer windows. Visible light is easily blocked by dust grains, but longer wavelengths can pass through with less scattering, revealing structures that are otherwise hidden. This is one reason our picture of the Milky Way has deepened so much in recent decades. We have learned to listen as well as to look, to gather information in many bands of light, each one offering a different view of the same environment. In radio observations, gas clouds can be traced across the disk. In infrared, we can see through dusty regions to the stars beyond. The galaxy, then, is not a single image. It is a layered story, and each layer can be felt as a different kind of quiet illumination. And closer again to our own gentle neighborhood, it helps to remember that even the sun is traveling through a local region with its own subtle features, its own clouds, its own boundaries of thin gas. We do not need to name those regions tonight. We do not need to turn this into a map with sharp labels. It is enough to sense that the galaxy is textured even at home scale. The space around us is not uniform. There are slightly denser patches, slightly emptier cavities, faint traces of ancient supernova, and drifting clouds that take vast times to cross. The solar system moves through these regions without noticing in any immediate way, the way a ship moves through a calm sea without feeling each gradual change in salinity or temperature. The Milky Way can hold variety without disturbance. The constellations we learn on Earth are local patterns, but the Milky Way's true structure is revealed by distance and motion, not by lines we draw in the sky. Constellations are comforting. They are human ways of arranging the stars into familiar shapes. But those shapes are made from stars at very different distances, moving on different paths through the galaxy. They only appear together because of perspective, because we view them from one small point within the disk. The Milky Way's own structure is different. It is made of gravitational relationships and shared rotation of where the gas is, where new stars form, and how mass is distributed. When you rest with that idea, it can feel like a gentle release. The sky does not need to be interpreted as a picture. It can simply be recognized as depth, as layered starlight, as a soft indication that we live inside something vast and steady. The Milky Way's stars follow orbits that are mostly predictable, and that predictability is part of what makes the galaxy stable over long times. The galaxy is not a chaotic swarm. It is dynamic, yes, but much of that dynamism is orderly. Stars trace paths determined by the galaxy's overall gravitational field, and while there are small perturbations and occasional close passes, the general behavior is smooth. That smoothness is what lets spiral patterns persist. It is what allows the disk to remain a disk, rather than dissolving into randomness. In a sense, the Milky Way is a grand example of calm complexity. Many parts, many motions, many histories, and yet a shared rhythm that holds them together. As you settle into that rhythm, you might imagine the galaxy not as something to comprehend all at once, but as something you can simply inhabit, the way you inhabit weather or night, or the slow turning of seasons. And from here, we can drift a little deeper into the way the Milky Way makes starlight, how it stores it, how it spreads it out across time, and how our own small region fits naturally into that larger, quiet rotation. The Sun moves through a small spur of the Milky Way's spiral structure, sometimes called the Orion Arm. This is not a grand, dominant arm that defines the whole galaxy. It is more like a gentle extension, a bridge of stars and gas that sits between larger spiral features. From within, that matters, because it means our local sky contains both the quietness of open space and the richness of nearby star-forming regions. Our neighborhood is not placed at a dramatic boundary. It is placed along a modest thread of the disk, where the galaxy's pattern is present without being overpowering. It is one more way the Milky Way feels inhabitable, like a landscape with both open fields and distant lights. Our region of the Milky Way contains large clouds of cold molecular gas, where future stars are quietly taking shape. These clouds are not bright to the naked eye. They are cold and dark, often hidden behind dust. Inside them, the gas is dense enough to form molecules, and that change matters. Molecular gas can cool efficiently, and cooling allows gravity to gather material into smaller and smaller pockets. In the calmest way imaginable, a cloud can develop knots and filaments, and some of those knots can become cradles for new stars. This is not an event that needs drama. It is a slow leaning in of matter, guided by gravity and time, taking place in the dark, out of sight, while the rest of the galaxy turns. The brightest young stars tend to live short lives, which is why they mark the Milky Way's most recent star formation. In our night sky, the very blue, very luminous stars are like brief flares of youth, not because they explode immediately, but because they burn through their fuel more quickly than smaller stars do. They do not stay around for as long as quieter, steadier stars. So, when we see clusters of them, or when we detect their influence on nearby gas. It often indicates a region where star formation has happened relatively recently in the galaxy's long timeline. This gives the Milky Way a subtle kind of freshness. Even in a system billions of years old, there are places where starlight is newly minted, and where the next generation has just begun to glow. Many stars in the Milky Way are smaller and cooler than the Sun, and they shine with a steadiness that can last for an extraordinarily long time. These stars do not dominate our view of the sky because they are faint, but they are common and they are enduring. Their light is modest, their warmth gentle, their lifetimes long. In the galaxy's overall story, they are the slow heartbeat, the constant background, the kind of star that makes the Milky Way feel less like a fireworks display and more like a stable environment. When you imagine the galaxy continuing quietly, long after any single human life, it is these steady stars that make that continuity feel natural. The Milky Way's disk has layers, including a thinner, younger component and a thicker, older one. From within, we experience the disk mostly as a band across the sky, but the disk has depth and history. The thinner component contains much of the gas and dust where new stars form, and it holds many younger stars that move in relatively orderly paths. The thicker component is more dispersed, with older stars that tend to have slightly different motions, as if they carry the memory of earlier eras when the galaxy was more turbulent. This layering is a kind of fossil record. It is not written in words, but in the distribution and movement of stars, showing that the Milky Way has settled and refined itself over time. The Milky Way's disk is not perfectly flat, but gently warped, especially in its outer regions. A warp is not a break, and it is not a flaw. It is simply the result of a galaxy being a living gravitational system, influenced by its own rotation and by the gentle pulls of its surroundings. Over great distances, the disk can bend slightly above and below its average plane, like a wide sheet responding to subtle forces. From our position, this warp is not something you notice directly in everyday stargazing, but it is part of the galaxy's shape, reminding us that even stability can include softness, and that flat in space often means approximately flat with graceful curves. The Milky Way's gravity is shared across the whole galaxy, so the stability we experience comes from the combined mass of many components. It can be tempting to imagine a single central anchor doing all the work, but a galaxy is held together by the distributed presence of matter across a vast volume. Stars contribute, gas contributes, dust contributes, and the larger, invisible halo of dark matter contributes a great deal, shaping how the galaxy rotates and how it remains bound. This kind of distributed stability is quietly reassuring. The Milky Way does not depend on one fragile point. It depends on the persistent collective pull of an enormous system, a shared agreement of gravity that keeps the disk coherent as it turns. Dark matter in the Milky Way is detected through its gravitational effects, not through light. It does not shine, and it does not block light in the usual way. We infer it because stars and gas move as though more mass is present than we can see. In that sense, dark matter is part of the galaxy's architecture, even if it is not part of the sky's visible beauty. And there is something calming in that too. The Milky Way is not only what appears, it is also what supports. There is an unseen structure that helps the galaxy remain stable over immense time, like foundations beneath a house that you do not need to think about to feel safe inside it. The Milky Way contains many regions where ionized gas glows softly, lit by the energy of nearby young stars. When a hot, young star shines strongly enough, it can strip electrons from the hydrogen around it, creating a faintly glowing region of ionized gas. These areas are part of the galaxy's ongoing cycle, where new stars not only form from clouds, but also reshape those clouds with light and heat. Over time, this can carve cavities and edges, creating rounded bubbles and delicate fronts where gas meets radiation. It is a slow sculpting, not a violent one, a reminder that light itself can be an organizing force in the interstellar medium, gently pushing and shaping what it touches. Supernova explosions have helped shape the Milky Way's interstellar space, creating expanding shells and hot, low-density cavities. When some stars end their lives, they release energy that drives shock waves into surrounding gas. Over long timescales, this contributes to the galaxy's texture. It can compress some regions, encouraging new star formation, while clearing out others, creating broad, thin bubbles of hot gas. Even if those events sound dramatic, their legacy in the scale of a galaxy can be surprisingly serene. The result is not constant chaos. The result is structure, a slow alternation between denser clouds and emptier hollows, like the grain of wood or the pattern of weather, spread across vast distances. The solar system appears to be traveling through a region of relatively low density interstellar gas, compared with denser star-forming clouds. This does not make us special. It makes us typical of a galaxy that has many different environments side by side. There are places thick with cold gas, and places more open, where the medium is thinner and calmer. Moving through such regions is part of the Milky Way's quiet change. The solar system's immediate surroundings can shift over time, not in a way you feel day to day, but in a way the galaxy gently experiences, as one patch of space gives way to another. It is like drifting through different air masses, only on timescales so long that the transition is more like a slow blending than a border. The Milky Way can be mapped using the natural radio signal from hydrogen, which reveals the shape of gas across the disk. Hydrogen, the most abundant element in the galaxy, can emit a characteristic radio wavelength that travels through dust with relative ease. This allows astronomers to trace the distribution of gas even on the far side of the galaxy, where visible light would be blocked. From this, the Milky Way's broad spiral structure can be inferred, not from a single photograph, but from patient surveying, from listening to the faint whispers of interstellar hydrogen. It is a gentle thought that the galaxy carries within it its own signals, quietly announcing where its material lies, and that we can learn our home not only by looking, but by tuning in. The motions of nearby stars, measured with great precision, have allowed us to build a far clearer sense of our place in the Milky Way. For most of human history, stars seemed fixed, like pinpricks on a dome. But in reality, many of them drift, ever so slightly, against the background over time. With careful measurements, those tiny shifts become a map of motion. They tell us which stars are moving with the general flow of the disk, which ones belong to older populations, and how the local neighborhood is structured in 3 dimensions. This is a particularly intimate kind of knowledge. It does not require us to step outside the galaxy. It simply requires us to watch long enough and gently enough to notice that the sky is alive with slow travelling. And as we rest within that living sky, it can be soothing to remember that even the stars we call fixed are companions in motion, each one following its own calm path through the same shared gravitational field, as if the whole Milky Way were a quiet, turning city at night, and we were listening to the soft, steady drift of its streets and its lights, and its long, unhurried flow through time, as the next layers of our galactic home continue to unfold. The Milky Way stars do not all share the same history, because the galaxy has grown by both forming stars and collecting them. A galaxy is not built in a single moment. It is assembled. Some of its stars formed in place from gas that settled into the disk. Others may have arrived as part of smaller systems that were gradually drawn in and mixed. This means the Milky Way is a blended community with different ages, different motions, and different chemical fingerprints moving together under one gravitational umbrella. There is a quiet comfort in that. Home is not always a pure origin. Sometimes it is a long accumulation, a gentle gathering, until the gathered parts become stable enough that they simply feel like one. Older stars in the Milky Way tend to be found in a broader, puffier distribution compared with younger disk stars. Over time, stellar orbits can become more stirred, more tilted, and slightly more irregular, especially for stars that formed in earlier, less settled phases of the galaxy. Many older stars therefore occupy a thicker layer around the disk, and some populate the halo and bulge. Younger stars, especially those born from the thin disk's gas, often stay closer to the midplane where the material is densest and the rotation is most orderly. This does not mean the galaxy is divided into strict zones. It means it has texture, like sediment layers in a calm landscape, each layer telling a story of conditions that were once slightly different. The Milky Way's central regions are rich in stars, but much of that starlight is hidden behind dust when viewed in visible light. When you look in the direction of the galaxy's center on a clear night, you may sense a thicker brightness, a richer scatter of stars. But what you see is only a portion. Dust in the disk blocks and reddens light, and the densest regions sit behind a great deal of it. The effect is like looking toward a distant city through mist. You can see the glow, you can sense the crowding, but the finest details remain soft and obscured. This is one of the reasons the Milky Way feels like a home you explore gradually. It does not reveal everything at once. It offers glimpses, and then it invites patience. The Milky Way's bulge contains many older stars, giving it a warm, steady glow when observed in wavelengths that can pass through dust. In infrared light, the galaxy's inner regions become more apparent. The bulge appears as a rounded concentration, a quiet swelling of starlight. Many of the stars there are older and cooler, and their light is less harsh and more golden than the blaze of young blue stars in star-forming arms. This changes the feeling of the center. It becomes less like a forbidden place and more like an ancient hearth, a region that has been steadily shining for a very long time, even when dust makes it difficult to see with ordinary eyes. The Milky Way's spiral structure is accompanied by subtle resonances, where stars and gas respond to the galaxy's rotating pattern in organized ways. A rotating galaxy has rhythms within rhythms. Some orbits align in ways that create long-lasting features, like rings, bars, or concentrations of gas. You do not need to picture this as mechanical. You can picture it as musical, with certain regions naturally reinforcing a pattern, the way a gentle echo can strengthen a note in a room. Over immense timescales, these resonances help shape where gas gathers, where stars form, and how the disk's features persist. The Milky Way, in this sense, is not only matter in motion, it is motion forming habits, and those habits becoming structure. The Milky Way likely contains a central bar, a stretched distribution of stars that influences the inner spiral pattern. From far away, many spiral galaxies show bars, and evidence suggests ours does too. A bar is not a rigid beam. It is a long, central concentration where many stars follow elongated orbits that collectively create a bar-shaped feature. This can guide gas inward and shape the arrangement of inner spiral arms. Even this feature, which might sound dramatic, is best imagined as slow and settled. It is a steady preference in how stars move near the center, a gravitational choreography that has taken a long time to establish, and that will likely persist for a long time still. Stars in the Milky Way can migrate inward or outward over time, without needing close encounters, simply through subtle gravitational interactions with spiral patterns. A star's orbit is not always fixed to one radius forever. Through gentle, cumulative effects, particularly in a galaxy with spiral structure, stars can shift their average distance from the center. This is not a sudden leap. It is a slow drift, a kind of long-term wandering. Over billions of years, it can mix stellar populations, blending stars born at different radii into a more interwoven disk. This makes the Milky Way feel less like a place with strict addresses, and more like a city where, over long lifetimes, residents gradually relocate and the neighborhoods become quietly mixed. The Sun's current neighborhood is not necessarily the exact region where it formed. If stars can migrate, then our own star may have drifted somewhat over its lifetime. That possibility adds a gentle layer to the idea of belonging. Home can be a path as well as a place. The solar system's current orbit is a continuation, not necessarily an origin point. And yet, wherever the Sun formed, it has belonged to the Milky Way the whole time, moving within the same gravitational environment, carried by the same rotation, sheltered by the same vast stability. The specifics can remain softly uncertain without disturbing the overall feeling of orientation. The Milky Way's stellar disk contains many binary and multiple star systems, where two or more stars orbit a common center of mass. Single stars like the Sun are not the only arrangement. Many stars form in pairs, and some in larger families. These systems are held together by their mutual gravity, and they move through the galaxy as one traveling unit. From a distance, they may look like a single point of light, but within that point is a quiet dance. Two stars circling each other, sometimes close, sometimes wide, sometimes with additional companions. This is part of the galaxy's subtle richness. Even when the Milky Way feels like a calm field of lights, many of those lights are themselves small systems, each with its own steady rhythm nested inside the larger rhythm of the galactic orbit. The Milky Way contains many planetary systems because planets appear to be a common outcome of star formation. We do not need to imagine every star with an Earth-like world. The details vary enormously, but the overall pattern is clear. When stars form, disks of material often form around them, and within those disks, planets can emerge. This means the galaxy is not just stars and empty space. It is likely filled with countless small worlds, most of them dark, most of them quiet, most of them circling their stars with no audience at all. It adds a gentle kind of fullness to the Milky Way. The lights we see are only the most obvious part of a much richer inventory. The Milky Way's star formation rate has changed over time, generally higher in the past, and quieter now compared with its more active phases. Galaxies evolve. They do not maintain the same pace forever. Early in its history, the Milky Way likely formed stars more vigorously when gas was more plentiful and conditions were different. Over time, as gas is converted into stars and as some is blown out or heated, the rate can slow. This does not mean star formation has stopped. It continues, especially in spiral arms and dense clouds. But the overall mood can become calmer, more measured. In a way, the Milky Way has aged into a steadier adulthood, still creative, still alive, but less hurried than in its youth. Gas in the Milky Way is gradually being recycled, with material moving between diffuse regions, dense clouds, and newly formed stars. The galaxy's gas is not a static reservoir. It circulates. Some of it is cold and dense, gathered into clouds. Some of it is warm and diffuse, spread between stars. Some is heated by young stars and shock waves, expanding into larger volumes. Over time, this gas can cool again, drift again, and be gathered again. It is a slow breathing of the interstellar medium, a cycling that allows the galaxy to keep forming stars without needing constant new supplies from outside. Even when the changes are subtle, the Milky Way is never completely still. It is quietly self-renewing. The Milky Way's disk is thin compared with its width, which is why the galaxy appears as a narrow band from our perspective. When you look at the Milky Way in the sky, the band seems slender, like a brushstroke. That is because the disk, while thick on human scales, is much thinner than it is wide. Most of the stars and gas are concentrated near the midplane. So looking along that plane gives you a long path through dense material, and looking away from it quickly takes you out of the main concentration. The result is a sky that is anisotropic, brighter in some directions, darker in others, not because the universe changes, but because we live within a particular shape. This is the gentle geometry of belonging. The sky's pattern is the galaxy's shape, printed on our view. The Milky Way's apparent brightness in the night sky varies with season, because Earth's orbit changes which direction we face at night. This is a quiet, familiar kind of motion. As Earth travels around the Sun, the night side of the planet points into different regions of the Milky Way. At some times of year, the denser galactic center region is more prominent in the night sky. At other times, we look outward, away from the center, into quieter stretches of the disk. This does not change the galaxy. It changes our orientation within it, like turning slowly in a room and noticing different walls. The Milky Way is always there. Our nights simply rotate their attention across its different depths. And with that gentle turning, you can begin to feel the Milky Way not as a distant spectacle, but as a steady surrounding presence, a structure you face from different angles through the year, while remaining safely inside it, moving with it, carried by it, as we continue drifting deeper into its quiet architecture. The Milky Way's night sky brightness is strongest where our line of sight passes through the greatest depth of the disk. When you look along the band, you are looking through a long corridor of stars. Some are relatively nearby. Many are far. Their light accumulates, layer by layer, until the sky becomes softly luminous in that direction. When you look away from the band, the depth quickly drops, and the sky becomes darker and more spacious. This is not a mystery or a trick of perception. It is simply what depth looks like when you are inside a flattened system. It can be comforting to recognize that the Milky Way does not demand you see the whole galaxy. It lets you feel its shape through quiet gradients of light. The Milky Way's dust does more than block light because it also helps cool gas clouds and supports the formation of molecules. Dust grains may be tiny, but they have large surfaces. In the cold darkness of interstellar space, those surfaces become meeting places where atoms can come together to form molecules, including the most abundant molecule in star-forming regions, molecular hydrogen. Dust also helps gas clouds radiate away energy, allowing them to cool and collapse more readily. So the same dust that creates those dark lanes in the sky is also part of the galaxy's long fertility. It is both veil and seedbed. It hides and it prepares, quietly shaping what the next generation of stars will be. In many parts of the Milky Way, starlight is filtered and reddened by dust, changing the colors of distant stars without changing the stars themselves. Light carries information, but it can be softened on the way to us. Dust grains tend to scatter shorter, bluer wavelengths more strongly, letting more of the red light through. The result is that distant stars can appear warmer in color than they truly are. This effect is gentle and pervasive, like seeing a distant landscape through haze at sunset. It reminds us that observation from within the galaxy includes atmosphere-like complications, not of air, but of interstellar material. Even so, there is no need to feel cut off from reality. The galaxy's dust is part of the reality. It is one of the textures of home. The Milky Way's gas is structured into filaments and shells, shaped by gravity, turbulence, and the energy from stars. Interstellar space is not a uniform fog. It is patterned. Gas can be stretched into long threads, gathered into knots, or carved into cavities. Some of this comes from gravity pulling material together. Some comes from the gentle churning of turbulent motion on huge scales. And some comes from the influence of starlight and stellar winds, which can push and compress gas over time. The patterns that result are often delicate and lace-like when we view them with the right instruments. They are the galaxy's weather, slow and wide, forming not in hours or days, but across ages. Many of the Milky Way's star-forming regions are hidden from ordinary sight, because they are wrapped in the same dust that helps them form. A nursery in space is often dark, not because nothing is happening, but because the very material that is collapsing is also absorbing light. Inside those hidden clouds, new stars begin as faint, warming centers, slowly clearing their surroundings. Over time, some nurseries become visible as they erode or disperse their dust, allowing their light to reach us more freely. But in the beginning, star formation often happens in private. It is like a candle being lit inside a closed lantern, its glow contained, until the structure around it changes. This makes the Milky Way feel quietly busy, even in darkness, like a city where many lights are behind curtains. The Milky Way's most massive stars can sculpt their surroundings by driving strong winds that clear and compress nearby gas. Starlight is not only illumination. For the hottest, brightest stars, it is also influence. Their radiation and winds can blow cavities in surrounding gas, creating expanding bubbles and bright edges where the gas is compressed. Those edges can, in turn, become new sites of collapse, where another generation of stars may form. This is one way the galaxy's activity can feel continuous rather than episodic. One set of stars subtly shapes the conditions for the next. It is not a chain of shocks. It is a slow relay, where energy moves outward and gravity gathers inward, and the two together maintain the galaxy's long, quiet productivity. The Milky Way's disk contains regions of relatively calm gas, as well as regions that are more turbulent and active. Not every place in the galaxy is a nursery. There are stretches where the gas is thin and diffuse, where the star formation is minimal, and where the environment is comparatively quiet. There are other places where clouds are dense and dynamic, where feedback from young stars stirs the medium and bright nebulae form. The coexistence of calm and activity is part of what makes the Milky Way feel like a real habitat, rather than a single scene. Like any large environment, it has varied weather, and we, in our own quiet region, are allowed to rest inside that variety. The Milky Way's stars carry chemical fingerprints that reveal where and when they formed. A star is made from the gas cloud that birthed it. The proportions of different elements in that gas become part of the star's composition, and they can be measured. Over time, this lets us read the galaxy's history in a subtle way. Older stars often formed from gas that contained fewer heavy elements, because there had been less time for previous generations to enrich the interstellar medium. Younger stars, like the Sun, tend to contain more of those heavier ingredients. In this way, the Milky Way becomes readable, not as a story with chapters, but as a continuous gradient, with countless individual lives contributing to the long, slow change of the whole. Some groups of stars in the Milky Way move together as streams, stretched out remnants of earlier clusters or absorbed systems. A stream is like a faint trail across the galaxy, made of stars sharing a common motion. Over time, gravity can stretch a once compact group into a long ribbon until it becomes difficult to see as a single object. Yet, it remains coherent in its movement. These streams are gentle evidence of time at work. They show that the Milky Way is not only a stable structure, but also a place where structures gradually dissolve, leaving behind subtle traces. Even the act of dispersal can be orderly, like ink slowly diffusing in water, creating patterns rather than mess. The Milky Way's halo contains very old stars that orbit in many directions, not confined to the disk's flat rotation. The disk has a shared flow, with most stars orbiting roughly the same way in roughly the same plane. The halo is different. Its stars can have more varied paths, some tilted, some elongated, some moving in directions that do not match the disk's orderly spin. This difference reflects different origins and different eras. The halo is, in some sense, the Milky Way's quiet outskirts and its ancient memory combined. It reminds us that the galaxy is more than what we see as a band. It is also a surrounding volume, with older components moving in broader, slower arcs around the whole. The Milky Way's gravitational field gently shapes the paths of comets and small bodies far beyond the planets. linking even the solar system's outskirts to the galaxy. The solar system has its own gravity, dominated by the Sun. But far from the Sun, where distances are great and the Sun's pull weakens, the Milky Way's broader gravity begins to matter more. Over very long periods, the galaxy's tides can subtly influence the most distant reservoirs of small icy bodies, nudging their orbits in faint ways. This does not mean the galaxy is tugging at everyday life. It means the solar system is nested inside the Milky Way's field, like a small eddy inside a wider current. Even at our farthest edges, we belong to the galaxy's quiet structure. The Milky Way is filled with cosmic rays, high-energy particles that travel through the galaxy and interact with its magnetic fields. These particles are part of the background activity of space. They are produced by energetic processes, including remnants of supernovae, and then they wander through the galaxy, guided and scattered by magnetic fields. You do not need to imagine them as a storm. They are more like a faint drizzle of particles moving through an enormous volume. Their presence is another reminder that space is not empty. It is active in quiet ways, filled with things that drift, collide, and change direction, all while the larger galaxy continues its slow rotation. And as all these subtle influences continue, dust cooling gas, stars shaping clouds, streams stretching, halos circling, and particles wandering, the Milky Way remains what it has always been for us. A wide, calm environment that holds our small planet without demanding our attention, carrying us through the night as we drift further into its gentle, steady motion. The Milky Way's spiral arms are traced not only by stars, but also by the distribution of gas, which responds strongly to the galaxy's gravitational patterns. Stars can drift away from their birthplaces, and over time, they may no longer mark the arm where they formed. Gas behaves differently. It is more responsive, more compressible, more likely to gather where conditions encourage it. So if you want to sense the galaxy's current structure, gas is a faithful guide. It outlines where the disk is most active, where clouds are gathering, and where the next generations are likely to appear. From within, this is another kind of orientation. Even though we cannot step outside to see the galaxy at once, the behavior of gas provides a quiet sketch, like a set of faint contours that reveal the shape of the land. The Milky Way contains rotating clouds of gas on many scales, from enormous complexes down to smaller clumps where individual stars can form. Rotation is a theme in the galaxy. The whole disk rotates. Many clouds rotate too, inheriting angular momentum from the motion of the gas that formed them. As a cloud collapses, this rotation can become more noticeable, and it can lead to the formation of flattened disks around young stars, the places where planets can later emerge. In that sense, the galaxy's large rotation echoes down into smaller and smaller systems, like a quiet motif repeating. The Milky Way's motion is not something separate from our story. It is the reason disks form at all, the reason orbits are natural, the reason stability can be built from movement. The Milky Way's overall shape has been slowly refined over billions of years through the balance of gravity pulling inward and rotation providing gentle support against collapse. A galaxy is, in a way, a compromise. Gravity wants to gather material. Rotation provides a tendency to spread it out, to keep it orbiting rather than falling directly inward. The Milky Way's disk is a long-term outcome of that balance. It is not perfectly rigid. It breathes, warps, ripples, and evolves. But it endures because the forces involved are steady, and because the system has had vast time to settle into a stable arrangement. This can feel soothing when you think about it as an environment. The Milky Way is not fragile. It is a structure shaped by the most reliable forces we know, given enough time to become calm. The Milky Way's disk can ripple with gentle vertical waves, likely stirred by past interactions with smaller galaxies. Even a stable galaxy can be nudged. When a smaller galaxy passes through or near the Milky Way, its gravity can create ripples in the disk, like a slow swell passing through a wide sheet. These waves are not something you would see with your eyes in the sky. They are detected through careful mapping of stellar positions and motions. Their presence is another reminder that the Milky Way has a history of encounters, not all of them disruptive, many of them subtle. And yet, the disk remains. The ripples are part of its livingness, like the faint lines on a calm lake that show it is connected to its surroundings. The Milky Way's stars do not orbit in perfect circles, but in paths that can be slightly elliptical and gently perturbed. An orbit in a galaxy is a practical path, not an ideal geometric figure. Stars move under the combined pull of distributed mass, and that pull can vary depending on local structures like spiral arms and the central bar. The result is that many stellar paths are close to circular, but not perfectly so. This imperfection is not instability, it is flexibility. It allows the galaxy to respond to changes and still remain coherent. It also means that stars can experience slight changes in speed and direction over time, like travelers adjusting their route in a large, flowing crowd, all without breaking the overall rhythm. The Milky Way contains regions where stars move in similar ways, forming kinematic groups that reflect shared origins or shared dynamical influences. In our local neighborhood, some stars can be found moving with similar velocities, not because they are bound like a cluster, but because they were once closer together, or because they have been shaped by the same gravitational features in the disk. These groups are like gentle currents within the larger flow. They show that the galaxy is not only a random assortment, it has substructure, memory, and coherence on many scales. To rest with that idea is to feel that even within vastness, there can be companionship in motion, quiet patterns that persist without needing to be named. The Milky Way's star formation is concentrated in the disk because that is where most of the cold, dense gas resides. Gas settles into the plane where rotation and gravity balance most effectively, and over time it becomes thinner and more concentrated there. Cold, dense gas is the essential ingredient for star formation, so star birth follows the gas. This is why the disk is both the brightest and the most productive part of the Milky Way. It is also why the band in the sky is so rich. When you look along it, you are looking through the zone where the galaxy most actively renews itself. And yet, even that renewal feels gentle when you step back. It is not constant fireworks. It is steady, distributed, and patient. The Milky Way's interstellar medium includes a hot, thin component that fills large volumes and can persist for long periods. Not all interstellar gas is cold. Some is heated to very high temperatures by supernova shockwaves and energetic processes, becoming diffuse and filling cavities. This hot gas is often invisible in ordinary light, but it is part of the galaxy's internal climate, providing pressure and influencing how other gas moves and cools. The coexistence of hot and cold, dense and thin, is one reason the Milky Way can be both stable and dynamic. It has multiple phases, like an atmosphere with different layers, each with its own behavior, all sharing the same overall rotation. The Milky Way's dust and gas can align with magnetic fields, causing faint polarization effects in the light we receive. Light can carry subtle orientation information, not just brightness and color. When dust grains align with magnetic fields, they can preferentially absorb or emit light with certain orientations, leading to polarization. This is a delicate signal, but it helps reveal the structure of magnetic fields across the galaxy. It is another way the Milky Way becomes knowable from within. Even without stepping outside, we can sense invisible frameworks through the quiet signatures they leave on light. The galaxy, in that sense, is not only seen, it is inferred patiently through layers of gentle evidence. The Milky Way's center is a region where stars orbit very quickly, responding to the strong concentration of mass there. Near the center, distances are smaller and gravity is stronger, so orbital speeds rise. Stars in the inner regions can complete their paths in far less time than stars in the outer disk. But this faster motion does not need to feel frantic. It is simply the natural response to a deeper gravitational well. The Milky Way contains a range of tempos, from brisk inner orbits to long, sweeping outer ones. Together, they create a galaxy that feels like a slow clock with many hands, each moving at its own pace, yet all contributing to one steady turning. Even though the Milky Way is vast, it is held together by gravity strongly enough that its stars remain bound in orbit rather than drifting away. This is the core of what makes a galaxy a home. It is a bound system. It is a place where motion does not mean escape. Stars move fast, and yet their speed is part of their belonging. The balance between motion and gravity keeps them on paths that repeat, paths that persist, paths that allow the galaxy to remain a recognizable structure for billions of years. The Milky Way is not a scattering. It is a congregation, a long-lived gathering in which everything is moving, and yet everything remains together. And as that togetherness continues, as the disk turns, as the halo circles, as gas gathers and releases, you can let your own thoughts loosen a little, the way dust loosens in a sunbeam, and simply rest inside the feeling that you are already in the galaxy, already carried by its steady gravity, already part of its quiet continuity. The Milky Way's starlight is not evenly distributed because the galaxy's disk contains both crowded regions and broad, quieter gaps. From within, this unevenness becomes part of the character of the night sky. In some directions, the stars seem sprinkled thickly, and the Milky Way's band looks textured and bright. In other directions, there is more breathing room, more darkness between points of light. This is not a flaw in the galaxy. It is a natural consequence of spiral structure, of clustering, of dust lanes, and of the simple fact that matter is never perfectly smooth. The Milky Way has regions of abundance and regions of spaciousness, and both belong to the same calm whole. Many of the Milky Way's stars are born in loose associations that drift apart, leaving behind only a shared motion for a while. A stellar association is like a neighborhood of young stars that formed from the same broad cloud, without being tightly bound like a dense cluster. For a time, those stars move together through the disk, sharing a direction, a pace, a gentle kinship. But the galaxy is wide, and its gravitational field is complex. Over time, small differences in orbit stretch the group, and the association dissolves into the general population. What remains is not a visible object in the sky, but the quiet truth that many stars you see as separate points may once have been part of the same birth story, gradually unbraiding into the larger flow. The Milky Way's largest star-forming complexes can influence their surroundings for a long time, even after their brightest stars have faded. When a region forms many stars, it does not simply return to quiet the moment the birth phase ends. The energetic effects linger. Gas can remain stirred, cavities can remain open, compressed edges can persist as future sites of collapse. Over time, those regions can become layered with generations, each one leaving a faint imprint on the local environment. It is like a landscape shaped by repeated gentle tides. The Milky Way carries these layered influences across the disk, so that even its quiet appearance from our viewpoint contains the residue of long, patient cycles. The Milky Way's thin disk is rich in circular motion, which helps keep stellar encounters relatively rare and allows long-term stability. In a crowded system where objects move in random directions, close encounters become more common. In the Milky Way's disk, many stars share a broad direction of orbit, like boats traveling the same way on a wide river. That shared flow reduces the relative speeds between many neighbors, and it makes the environment calmer in a dynamical sense. Encounters still happen, and gravity still tugs, but the overall pattern is orderly enough that solar systems can persist for long times without frequent disruption. In that steady ordering, you can hear the galaxy's quiet preference for continuity. The Milky Way's stars are separated by immense distances, so even in dense regions, space remains overwhelmingly open. A crowded patch of sky can give the impression of closeness, as if the stars are packed like grains of sand. In reality, the gaps between them are vast. Light crosses those gaps, gravity reaches across them, and yet the physical space is still mostly emptiness. This is one of the gentlest truths of the galaxy. Even where the Milky Way is most luminous, it is not cramped in the way our intuition might imagine. It is spacious, airy and open, with stars as distant islands of light, bound together not by proximity, but by shared orbit and shared gravitational belonging. The Milky Way's most common kind of star is faint, which is why the galaxy contains far more light sources than the naked eye can ever show. Your eyes reveal the brighter and closer stars, the ones whose light stands out. But the galaxy is filled with smaller, cooler stars that are difficult to see individually from Earth, without instruments. They add to the Milky Way's mass and to its long-term steadiness, even if they do not dominate its visible beauty. In a sense, the Milky Way's strength comes from quiet contributors. Many faint stars, each modest on its own, together forming a large part of the galaxy's population, and together helping to shape the gravity that holds the disk in place. The Milky Way's stellar populations can be grouped by age, and those ages reflect a slow history rather than a single burst of creation. Some stars formed early, when the galaxy was still assembling and the environment was more turbulent. Others formed later, from more settled gas in the disk. This means the Milky Way is not a snapshot. It is a layered timeline. If you could sense the ages of stars the way you sense warmth, the galaxy would feel like a landscape with ancient stones and fresh leaves together, coexisting without conflict. And because the timescales are so long, the changes from one era to another are not abrupt. They blend, like dusk blending into night. The Milky Way's brightest visible band is only part of the galaxy's true extent, because the halo stretches much farther into space. The sky's milky ribbon is the signature of the disk, where the stars are concentrated. But beyond that, the galaxy extends into a much wider volume of faint stars and dark matter. The halo is not obvious to the eye because it is diffuse and dim, but it is part of the same bound system. Thinking of it can soften the edges of the Milky Way in your mind. The galaxy is not a flat strip alone. It is a surrounding presence, a wide envelope, like a quiet outer room beyond the main lights. The Milky Way's globular clusters act like ancient satellites, each one orbiting the galaxy with its own steady period. A globular cluster is dense, old, and enduring. It travels around the Milky Way like a loyal companion, held by the galaxy's gravity, yet separate in its own identity. Inside, stars are packed more closely than in our local neighborhood, and many have been shining since the galaxy's early epochs. From within the Milky Way, these clusters are reminders that some structures can survive for immense times without dissolving. They are small, stable worlds of starlight, circling quietly in the halo, keeping their shape through the long turning of the galaxy. The Milky Way is part of a larger community of galaxies, and its motion is influenced by that broader environment. Even though our focus is the Milky Way as home, it is still part of a neighborhood. The local group contains several galaxies, each with its own gravity, each moving relative to the others. Over time, these relationships matter. They shape the paths of companions. They contribute to gentle tidal influences, and they have likely played a role in the Milky Way's past growth. But the important feeling remains calm. The Milky Way does not drift alone in emptiness. It belongs to a wider family, and that wider family helps define the long-term context in which our own galaxy continues its steady rotation. Within the Milky Way, gravity acts as a kind of quiet communication, linking distant parts of the galaxy without needing contact or signal. Gravity does not need a wire or a beam of light. It is simply the shared field created by mass. It shapes orbits, gathers gas, and maintains the galaxy's overall form. In that way, the Milky Way is cohesive even across its vastness. Each star responds to the whole, and the whole is shaped by the collection of all stars. This is a particularly soothing kind of connection. It is not loud. It is not demanding. It is simply there, a constant, gentle influence that keeps the galaxy feeling like one place rather than a scattering. And as you rest inside that sense of connection, you can let the idea settle that your own stillness does not contradict the galaxy's motion. Both can be true at once. You can be at rest and still be carried quietly through a structure that has held together for ages and will continue to hold together as the Milky Way turns on and on through the dark. The Milky Way's oldest stars are quiet reminders that the galaxy has been stable for a very long time. Some of those ancient stars have been circling in this same gravitational home since long before the Sun existed. Their light is different, often softer, and their motions carry the calm imprint of deep time. They do not announce themselves loudly in the night sky, yet they are part of the Milky Way's long memory. They tell us without words, that the galaxy is not a passing scene. It is an enduring environment, one that has held together through eras so long they feel more like geology than history. And even now, as you rest, those old stars continue their slow travel, as if nothing needs to change quickly in order to be alive. The Milky Way's gas continues to settle, drift, and gather, even in regions that look dark and still. Across the disk, clouds thin out and thicken, not as sudden events, but as gradual tendencies. Material moves through the galaxy in slow circulation, cooling here, warming there, gently responding to gravity and to the faint pressures of its surroundings. In many places, nothing dramatic happens at all. A cloud may simply exist, dim and quiet, shaping the space around it. In other places, a cloud may slowly become a little denser, a little more organized, like breath drawing in. The important thing is the pace. The Milky Way does not hurry. It continues by small shifts and patient balances, like a landscape that changes without ever needing to start over. The Milky Way's spiral structure persists because the galaxy's motion is orderly enough to maintain long-lived patterns. The disk turns, and within that turning, certain regions remain gently favored. Gas collects more readily, star formation occurs more often, and the overall shape keeps its familiar character. From inside the galaxy, this is not experienced as a swirl you can watch. It is experienced as continuity. The same broad directions remain rich with stars. The same band remains, night after night, as a steady presence across the sky. The pattern is not frozen, and it is not perfectly fixed, yet it endures because the Milky Way's motion is not chaotic. It is guided. It is held. It is the sort of movement that can repeat and remain recognizable. The Milky Way's gravity continues to hold the galaxy together without strain or effort. Gravity is not loud. It does not flicker. It does not need attention. It simply exists as a steady pull, linking distant parts of the galaxy into one bound home. It keeps stars in orbit. It keeps the disk coherent. It keeps the halo attached, wide and faint, surrounding the brighter plane. This holding is not something you have to imagine as a force you can feel. It is more like a quiet certainty, like the way a floor supports you without asking you to think about it. The Milky Way's stability is built into the fabric of its motion, and that stability continues whether you are awake, half asleep, or already drifting. Starlight inside the Milky Way is always on its way, traveling calmly across great distances. Light does not arrive all at once. It moves. It streams outward from stars and passes through the thin interstellar medium, through faint dust, through open space. Some of it reaches us directly. Some of it is softened along the way. Some of it never reaches us at all. But the movement continues, silent and constant. It is not a message that demands to be read. It is simply the galaxy shining, as it has always shone, filling the disk with gentle illumination. Even when the night looks dark, even when your eyes are closed, the Milky Way is full of light in transit, quietly crossing the space between stars. The Milky Way changes slowly enough that its present is made of long continuities, not sudden turns. Over time, stars age, clouds shift, orbits adjust by tiny amounts. The galaxy is always evolving, but it does so in a way that keeps its overall character steady. It remains a disk. It remains a home of rotation. It remains a place where the same general structures can persist, while the details gradually renew themselves. This kind of change is reassuring. It means that the Milky Way can be alive without being unstable. It can move without being restless. It can hold countless paths at once and still feel like one coherent environment that carries everything together. The Milky Way has room for both activity and quiet, and most of its volume is gently quiet. There are places where stars are forming and where gas is stirred. There are also immense regions where nothing seems to happen quickly at all. Wide distances where the interstellar medium is thin. Long stretches where stars simply follow their orbits, keeping their pace, keeping their distance, keeping their steady light. When you picture the Milky Way as an environment you inhabit, it can help to feel the proportion of stillness within it. Most of the galaxy is spacious. Most of it is calm, and even the active places are active on timescales that are slow, patient, and unhurried. And now, without needing to hold on to details, you can let the Milky Way become less of a subject and more of a setting, like the night air beyond the window, like the quiet weight of a blanket, present, steady, and not asking anything from you. You do not need to picture the whole galaxy. You do not need to remember names or shapes. You can simply allow the sense of being inside it. The Milky Way is around you in every direction, even when you are indoors, even when your eyes are closed. Above the ceiling, above the clouds, above the thin upper air, the Earth continues its familiar spin, and the Earth continues its path around the Sun, and the Sun continues its path through the galaxy. This layered motion does not disturb your rest. It supports it. It means that everything is already taken care of by the quiet physics of orbit and balance. Nothing is required of you. The galaxy is moving whether you follow it or not. You can let your attention soften into that idea. A home that moves and yet remains steady. A place where motion is not urgency, but rhythm. Somewhere in the Milky Way, stars are being born in darkness, not as a sudden spectacle, but as a gradual gathering of material, a slow warming, a quiet beginning. And elsewhere, older stars are cooling into later stages, shedding their light more gently. The galaxy contains beginnings and endings at the same time, spread out so widely that they do not compete. They simply coexist. The Milky Way can hold countless life cycles without becoming crowded by them. It is spacious enough for everything to unfold at its own pace. And in your own small part of it, your only task tonight is rest. You are allowed to stop tracking, allowed to stop holding the thread, allowed to simply be carried. The galaxy does not become more real when you concentrate on it. It is already real. It is already here. It is already holding its shape, turning slowly and letting everything within it continue. So you can release the need to imagine distances. You can release the need to count time. You can let the Milky Way become a background presence, like a low, steady note. A wide disk of stars and dust, rotating quietly. A soft band across the sky, whether you see it or not. A calm gravitational home, surrounding you in all directions. If thoughts come, they can come. If they drift away, they can drift away. Nothing needs to be solved. Nothing needs to be completed. The Milky Way will keep turning. Stars will keep their orbits. Light will keep traveling. Gravity will keep holding. And you, right now, can be as still as you need to be. You can let your body sink into the bed. You can let your breathing slow. You can let the day fade out at the edges, the way starlight fades softly through dust. without struggle, without effort. Somewhere above you, far beyond the everyday world, the galaxy continues, immense and quiet, not watching, not waiting, just continuing. You are inside it, safely. You belong to its motion without needing to move. You belong to its continuity without needing to understand. And as the Milky Way carries on, you can allow yourself to carry on into sleep, gently, easily, in your own time. Good night.